All right, I have a late start because I unexpectedly had to register my phone number, so I've never had to do that before. Whatever. You're given an integer array nums. An element nums I is considered valid if it satisfies at least one of the following conditions. It's strictly greater than every element to its left. It is strictly greater than every element to its right. The first and last elements are always valid. Why are the first and last elements always valid? Strictly okay. Is valid I. So if I equals 0 or I equals length nums minus 1, and return true. Strictly greater. So there can be only one, right? This is dumb. This equals counter of nums. Alright. R equals that. R dot, well, nums 0. And then R, well, we'll do it like this. Nums -1 max of nums. All right. Now, if R of 0 equals R of 1, or R of -1 equals R of 1, then that's instant disqualification. R dot pop 1 and return R. Alright, so if C of R of 1 is greater than 1, I think we could put this here. I mean, it's the same code. All right. Run. Output. One, 4, 2. What? Strictly greater than every element to its left. Oh, one of the following is true. Idiot. Check left. Yeah. Return max. If I is less than 0, then return, I don't know, 0, I guess. Otherwise, return max of nums I, comma, CL of I minus 1. And are you cache? None. This is going pretty poorly, so check right. Okay, if it's greater than or equal to length of nums, then return 0, otherwise return max, right? And then return n for I, comma, n in enumerate nums if check left of I minus 1 is lesser than n, or check right of I plus 1 is greater than n. Unexpected indent. This index out of range. I gotta be honest with you, that's kind of strange. Because it's supposed to be going down, and this is supposed to be going up, right? Print. I don't know, I. Why is it going up? Did I pass the wrong value or something? Zero, 1, 2, 3, 4, 5. Indeed. See, I got it. So far off to a bad start. 1, 2, 4, 2, 5. What? No, this should have worked for the edges. This should have worked for the edges. Five, 5, 1. Oh God, okay. Sort vowels by frequency. You're given a string S consisting of lowercase English letters. Rearrange only the vowels in the string so that they appear in non-increasing order of their frequency. If multiple vowels have the same frequency, order them by the position of their first occurrences in S. Sorting in non-increasing order of frequency. So decreasing order of frequency. Okay, now it's the position of their first occurrence in S. The first. Okay. That's fine. Okay, so C equals counter, right? And they are lowercase, right? Yeah, for I, comma, this. So vowel set equals set of A, E, I, O, U. All right. Relevant. Okay. So if CH in VS, oh my god, then relevant dot append, I guess I dot ch, right? Well, yeah, no, that's fine. That's fine. Okay. First, if CH not in first, if CH not in first, then first of CH equals I, right? So we're going to have to go through and we're going to have to replace these. Yeah. So, sets equals for k in first dot keys, so that'll give us a list of every letter, and then we need it sorted by the frequency, right? Sorted by the frequency. So counter of k, and then the secondary thing is the first location, first of k, right? And then the actual letter is right there. So yeah. All right then. Actually, I'm gonna need to modify this. So we'll go like that. So for I comma C, well, doesn't matter what it was. In relevant, okay, if sets of 0 of 0, sets dot sort. Oh. Hold on. List of reversed of sorted. Like that. So if sets 0, 0 less than or equal to 0, well, sets dot pop 0. Now we are going to go sets 0, 0 minus equals 1 because we're going to consume it, right? And then we need to update the value. So ret list equals list of s, I guess. We can't edit a string directly. So ret list of I equals sets 0 of, what's the character, 2? Yeah, that sounds good. So return dot join ret list. Life is pain. List index out of range. There should be exactly the right amount. Well, we're only enumerating the relevant ones, though. Oh! We didn't increment the counter. That was dumb. That was so dumb. Actually, let's just do it like that. That's probably wasteful, but whatever. I don't care right now. Leetcode, right? Leetcode. Here we go. Oh, and boyo. Submit. あれは面白いね。So there is something wrong here. Okay. Should be returning. Oh, damn it. It's completely backwards. There we go. Okay, B-A-E-I-O-U. B-A-E-I-O-U. Submit. Alright, accepted. Minimum operations to make array non-decreasing. You're given an array nums of length n. In one operation, you may choose any substring, nums L through R, and increase each element in that subarray by x, where x is any positive number. Return the minimum possible sum of the values of x across all operations What the hell? One optimal set of operations is 2 to 3 add 1. Non-decreasing, so increasing basically. The array becomes non-decreasing and the total sum chosen. I mean, is there any reason that we can't just increase the entire rest of the array by the minimum amount to make the next element that doesn't work big enough? Because we're not being punished for the length, and we only want the values to the right to increase, right? Is there any reason that we wouldn't want something further to the right to increase? I can't think of one. Now, we might not want something to the left to increase, but if the offset is the same, it shouldn't matter, right? Am I doing that right? Let's try a proof by contradiction. Let's say we have some number A, B, C, D, E, F. Okay, and we are saying that for some reason incrementing only B is preferable to incrementing every other thing. Right? This would go up by 1, and the only relationship that this could have with things to the right would be the only thing that could happen is that these would need to be increased. Now there are relative differences, but there's none. Like if we could skip C or something, then maybe. I think that this is one of those math trick ones. So, an integer array nums of length n. You may choose any subarray and increase each element in that subarray by x, where x is any positive integer. Two to 3. Here, let's do the actual example. So 3, 3, 2, 1, right? 0, 1, 2, 3. Yeah. And then it doesn't matter. It's just whatever it is to the right because you've adjusted all of them. So you don't even need to remember what you incremented, right? So we will say for I in range length nums, but we're going to start from 1, right? CNT equals 0. So anything that was applied to something later can be applied to something earlier. Because we only have to bring it up to where it was, right? Yeah. So if nums of I is less than nums of I plus, or not plus 1, minus 1, then CNT plus equals that times CNT. All right, 2, 4. All right, sweet.